Now that we have the OWASP Juice Shop deployed to Heroku and we have Burp configured to trust a certificate authority, allowing the secure requests to come through uh, through the Juice Shop onto our computer and out onto the internet. It's time for us to begin enumerating the OWASP Juice Shop. And as we can see, Burp is already starting to track a bunch of SVG files that are sitting there on the root folder for this domain. You can see an API folder, some different assets. I can continue scrolling all the way down. See some socket.io. We see a style sheet. And we see a variety of other things. So that's all fine and good. I'll just scroll right back up to the top for the sake of brevity here. If we think back to some of the lessons that we saw earlier in this course, enumeration is key to identifying the technologies that a given website is using, and we want to replay a lot of the exercises that we performed earlier in the course to help us learn more about the Juice Shop. Certainly, I could download a variety of extensions for Firefox. You can see here in Hack the Box, it already has Wappleizer installed, so I can start to look and see, okay, we've got Angular 13.3, we've got jQuery, it's deployed on Heroku, it's programmed using TypeScript, so this is all really great general information. The first thing you really want to do as an attacker with Burp running in the background is to look at the website by itself in its natural form, looking at things from the perspective of a legitimate user, not necessarily as an attacker quite yet. So let's get a sense for what the OWASP Juice Shop is. We see a bunch of products. I can click on a product. Tells me it costs $1.99. Maybe it's got some reviews. You can see somebody with the username admin at Juice Shop said that the apple juice here is one of their favorites. I can continue scrolling down. Maybe look at only one left is the Juice Shop salesman. Yeah, one's $5,000. It's got a couple of reviews, and Stan Bender, again from at Juice Shop, have left reviews on this product as well. Perhaps we want to go check out what else is on the site. We can see there's an About Us page. We can go check that out. On which we see a bunch of dummy text as lorem ipsum text, although it does have a link out to some terms of service, which looks like it goes to, if you see down there in the lower left corner, it's going to a legal.markdown file. Here we can see some customer feedback that's appearing with different star ratings. You might look at the customer feedback. Oh, there's a form where we can enter some data. Maybe we want to type in, looks like we're stuck as the anonymous user because we're not logged in. You can say, Juice Shop is delicious. Maybe give it a rating of, give it a 4-star rating. And there is some sort of CAPTCHA on here. So what is 6 minus 2 times 4? This might take me a moment to think the order of operations. I think we do, I think we just do left to right. So 6 minus 2 is 4 times 4 is that 16. And I'll submit that. Oh, that's not the right answer. Maybe it's 2 times 4 first, so that's 8. 6 minus 2 is that negative 2. And it looks like that submitted things just fine. And go check out some other things on here. I mean, if I wanted to follow some links out to, I don't know if these link to anything. I can maybe click on account and log in. Maybe type in something like admin at Juice Shop with a password of, I don't know, you think it's password. See if that works. It does not. Again, in the background, Burp is checking out all of the requests that we're making. So if I scroll all the way down to the bottom, we should see the last thing should have been a post to the login page. So you can see I gave it an email and a password, and the response was invalid email or password. So that's all pretty cool. Instead of just beating the dead horse and clicking through everything in the website here on the video, this is definitely something I would encourage you to do as the student of this course. In the interest of time, I want to pivot to some of the lessons that we learned from the cyber scavenger hunt. And if you recall, one of the very first lessons that we covered in the cyber scavenger hunt was to think about what Google is going to see when the Google search crawlers hit this site. And so maybe what I'll do is chop all of that off there and put robots.txt. And let's see what the developers didn't want us to find. Well, the developers didn't want Google to find this FTP folder. So immediately the first thing we're going to do is delete off robots.txt, and we're going to go to /FTP. And so what we find here, again, very similar to the cyber scavenger hunt, is a folder containing assets that aren't necessarily part of the web application. If you think about the web application as the JavaScript and HTML assets, this folder is just an open file for us, an open folder for us to browse on the internet, as if you had just exposed a folder on the web server. And we can see different files in here. Looks like that legal.md file was what we had read earlier, but there appears to be some sort of Easter egg as an acquisitions.markdown. So again, if I were to read that, maybe we can open that. Let's see what happens when we open this file. It's a confidential document. Look at that. This is a contrived example. Obviously, it's using lorem ipsum text. It's not fake news. But the real world implications of finding a file like this are pretty obvious, and it all boils down to the fact that there was this unsecured open FTP folder. So that's definitely something that an attacker is going to be digging more closely into. Because we've got some sort of encrypted announcement, we've got some coupons, some incident support, suspicious errors. These are all the kinds of files that would be super interesting to an application developer. Well, now we're back at the Juice Shop, and it's time for us to apply another lesson that we've learned in this course, one that might be pretty useful in this case. It's one of my favorite parts of the OWASP Juice Shop. Let me just make this a little bit bigger, because I would like to open, in this case it's Firefox Developer Tools. I'm going to dock this to the right. I like to have things docked to the right. I think they're a little easier to read. You'll recall a bonus lesson that I taught earlier in the course that involved looking at the source code to find any client-side routes that may exist. And this is a perfect opportunity for us to go and find any potential hidden routes to the application, because we know it's built using a modern version of AngularJS. And if it also wasn't obvious, anytime you see a hash mark up here in the URL, so domain.com/hash, and the browser knows to mostly ignore anything that comes after that hash, meaning the application, the web server knows that if you're requesting the asset from the root, so it's basically like your index.html, and there's a hash mark that comes after it, the browser is only going to request that index.html file, and it'll mostly ignore what comes after that in terms of a request that goes to the server. The bit that comes after the hash mark is used by the client-side JavaScript to interpret what part of the application should be displayed on the screen to the user at any given time. So here in our debugger panel, again, this is very similar to the Chrome DevTools. Things are named a little bit differently, but you kind of get the same idea. You'll recall I said to look for a file named main.js. Maybe we'll expand some of this outwards. I'll do pretty print. And I do Control F, and so we'll look for the word path, colon, and we put a space, and no space with a double quote. Oh, there's a path somewhere in here, and let's just, for the sake of argument, go backwards, because for whatever reason, these tend to be at the bottom of the file. We can see a lot of paths that look like they might be related to client-side routing. In fact, let's continue scrolling here. See if I can find one that looks interesting. We've got payments with a colon identity, a wallet, forgot password, two-factor authentication. Let's just see what else we can find in here. There's a really interesting one. Here we go. Scoreboard. That looks like an interesting one to me, even though it's not necessarily security related in the sense of logins, encryption, things of that nature. The scoreboard looks like something that's kind of out of left field. So maybe I'll replace login with scoreboard. And what we can find is actually a scoreboard for the application. And I'll close my DevTools just to make this a little bit bigger. This right here is my favorite part of the OWASP Juice Shop because it tells you how many vulnerabilities exist in this app, and it gives you effectively a progress report for identifying all of the different vulnerabilities that exist in the app and whether or not you've been able to exploit them. Right off the bat, it says we've solved 2 out of 12 at level 1. And if we scroll down for a moment, let me get rid of this thing. What can we find? We found a solve. We found a confidential document that we found in the FTP folder. So that was great. What else have we found? We found the carefully hidden scoreboard page. But we can see there's all kinds of other things in here. We have being able to give 0-star feedback. We're going to come back to that one here in a few minutes. We can look at DOM-based cross-site scripting, different kinds of error handling. I would highly encourage you to pursue each of the vulnerabilities you see listed here in the scoreboard, following along with the Pwning OWASP Juice Shop book. If you're unsure how to get past a certain challenge, you will learn an immense amount about web application security just going through the items here on the scoreboard. Some of them are easy, like the 2 that we just found. Some of them are insanely difficult. So buckle up and get ready for some additional learning. We're going to go through 3 more of these before this video is over here today. So rather than picking the vulnerabilities that we see listed here, because that wouldn't be a fair way to do it, let's jump back to the home page for the Juice Shop, and we'll try to find a vulnerability that might exist somewhere. So in the searching that we did a little bit ago, we looked at the different kinds of products that this juice shop sells. We see banana juice, we see carrot juice, we see egg fruit. Although egg fruit, I'm not even sure if that's a real fruit. That's a silly name for something. Different kinds of smoothies or a fruit press. Let's see if we can't come up to the top here. Let's do a little bit of searching. Let's look for let's look to see what kind of smoothies the juice shop sells. Well, apparently it only finds a single smoothie, but for the sake of our example, this is actually pretty good for us. What we'll notice is that I've typed in the word smoothie here in the search bar. The word smoothie appears here on the screen. It also appears up here in my URL bar. So as an example, if I were to just chop off the IE and say smooth, and then hit enter, well, we'll see it actually updates smooth here in the DOM. It did not update my my input box up here. That's a curious finding by itself, but the fact that the URL updated to find something here with smooth tells me that perhaps this is an opportunity for some kind of template injection. So we think about the kinds of things a malicious user might want to type into an input box. We could say, we type in like a script tag and have an alert that's going to put the number 42, and we'll type in that. Well, that didn't work, but I will point something out. The text I typed here does appear up here in the search bar. It does, however, not appear down here in the DOM, which is curious. I would have expected, if there was proper sanitation happening at the document object model level, that perhaps some sort of sanitized version of my input would appear here, but nothing does. So again, if we inspect element, we open this up, I wonder if we're going to find anything in here. So we've got search results and then a search value. We see it did actually try to put the value I typed in there. It just didn't execute my JavaScript. So thankfully there's some good sanitation happening here. On the other hand, now that we have pretty good confirmation that the raw content that we are providing this will be injected directly into the DOM, you can see it's not escaping any scripts here. It's just not executing that code for some unknown reason. Perhaps there's a different cross-site scripting payload that we want to try. And one of the ones that I usually lean towards first is some sort of image tag that has no source attribute and has an on-error attribute inside of which might be some bit of JavaScript that we want to execute. So in this case, it'll just be in a workbox. So if I hit enter, what do you know? You have a cross-site scripting vulnerability on this page, and that can be executed in one of two ways. Certainly, you can type it directly into the search box, but that's an attack that has limited impact, because really, if you're going to type in cross-site scripting into an input, and then you have to hit enter yourself, you're really just cross-site scripting yourself. There's no way to attack another user. But if I could take this entire URL that does include my search query as part of it, and I send that to another user, maybe in Slack or via email, somebody will click on it, and this JavaScript payload inside of my on-error attribute will execute for the user who clicked on that link. This could potentially expose a cookie value, a JWT that could be stored in local storage, really anything that the developers left in the runtime of a browser can be grabbed using JavaScript and executed, perhaps even exfiltrated, again, because we're able to execute arbitrary JavaScript. We can grab hold of somebody's JWT, send that to a command and control server, and then we're off to the races as an attacker. So I don't know if Juice Shop is going to give me credit for this specific payload if I worked 42, but there is a specific payload if you went back to the scoreboard. It'll tell you what the specific cross-site scripting payload it expects to give you credit for finding that vulnerability. But just know that this is the place where you would potentially do it, and this is how we found that as we were thinking like an attacker. Well, the next item that we're going to look at, we did find on the scoreboard, though we actually found it before we got into the scoreboard. It was an item that we had tracked in our initial clicking through manual enumeration of the site. And that has to do with the feedback that we can give to the owners of this application. Let me close my DevTools. Let me click over here. We'll go to customer feedback. And you'll recall that we found this form where we could input some comments that get sent to the developer of the application. And it does have a CAPTCHA. For the sake of argument, we'll just say blah, blah, blah. 1 plus 9 plus 4. We all know the answer to this is 14. And I didn't give it a rating yet, so we'll give it a 2-star rating, and we'll hit submit, and that's that. Well, if we go to Burp, and we scroll down to the very bottom of our HTTP history, where we found API feedbacks, and you can right-click and we can send this to Repeater. You can see briefly it highlights Repeater in orange. It's not very obvious. This is something, if you're new to using Burp, you might not have caught that quick change to orange there in the text color. But we'll come here and we'll see this tab listed number 1. And if you double click in it, you can actually type in here to give you a little bit more context as to what's in here. I'm going to say customer feedback is the name of this request. And you can see it's posting to API/feedbacks, and we're giving it a CAPTCHA ID, a CAPTCHA, and a rating, as well as some comments. The scoreboard was trying to ask us if we could find a vulnerability by which we could provide a 0-star rating to the application. Looking at the interface on the web, you'll actually see the lowest it can go is 1, the highest it can go is 5. So just using the user interface, there's no way to provide a 0-star rating. Perhaps by editing this request here in Burp, I can hit send, and I have a success for the 0-star rating. I don't know if you caught it quickly in the background of Juice Shop. It gave this little blast of confetti, and it says we successfully solved a 0-star challenge. The moral of this example is that using Burp, it's really easy to replay different API requests that get made. All we have to do is change the inputs that get provided. I could try giving it, instead of a 0-star rating, can I give it a rating of 42? I'll send that. And apparently that allowed us to do a 42-star rating as well. I wonder if I could try a negative number on here. I wonder if there's any validation whatsoever. That one also appears to be successful. I could try giving it a non-numeric value, maybe a rating of true. See what that does. That seems to be just fine. Maybe no rating at all. No rating at all gives us an error message. And again, you see that blast of confetti there in the background. This error message is something that should probably be suppressed in a production application, but we'll see from the Node.js layer, or you can see express lib router index.js. There's some sort of unexpected token. That's because we provided either a null or an undefined value to the API. The API was not expecting that kind of a value, and so it just blindly passed that value on to whatever layer comes beneath the API. Maybe it's a database request, maybe it could be any number of things, but that unsanitized value created some runtime error in the backend, and that allowed us to identify some additional information about the server. Now that we have this error message, we know it's running Node.js. So Burp Suite makes enumeration really easy, provided you take the time to play with different inputs that you see here in Burp Repeater. Well, let's move on to one final example of the Juice Shop, just to reinforce some of the lessons that we've learned in this course. Let's click on the account button. Takes us to the login screen. We saw this before. Let me clear these two warnings at the top. And we did before try to do something like admin at Juice Shop, and we gave it like a password, and that email or password was not correct. There's a couple of different approaches that we might take at this point. One could be to use Burp Suite again. If we wanted to come back, let's go find that request that we made to the login. And instead of using Burp Repeater, let's send this to Burp Intruder. And you'll see the Intruder tab highlight orange. And we'll see over here we've got a number 2 tab. And we'll say this is login, so we don't get lost in the number of tabs that appear. And Burp Intruder takes a little bit of configuration in order to start using it. We could do something like looking at the different positions here. The first thing I want to do is hit clear. We'll see all of these items highlighted in green with the, I don't know what kind of magical symbol this is surrounding these different values, but I'm going to hit clear. And instead of blindly doing all of them, I'm going to highlight the word password, and I'm going to say add. So now this is the only variable in this entire request. This request looks identical to what we saw in Burp Repeater, only we're telling Burp Intruder that we want to swap this value out dynamically as we begin to attack this endpoint. If we go to payloads, Burp Intruder has a number of different options and a number of different attacks that you can do. There's different kinds of payload types. There's different kinds of attack patterns. I'm going to keep this simple because you can easily look on YouTube or Google for different resources on how to use Burp Intruder. But for the sake of argument, let's say I manually input some potential items of a word list. I could say maybe admin. I could do password 123. I could say 1, 2, 3, 4, 5, 6. You get the idea. This is just a very small word list. And I'll just hit start attack. And this will pop open a window where you'll see it gives me the first item it sent was an undefined value. You can see the actual request that got made here. So sent a password, and then it sent admin, and then it sent password 123, and then it sent 1, 2, 3, 4, 5, 6. If you had a sufficiently large word list, Burp would try every combination in that word list, and it would give you all of the the different requests and responses here in this top section. And you might be able to sort this list then to say, well, if I sorted it by status code, if anything was not a 401, that might indicate either that it was successful or that some other kind of error happened. And the same might go for length, where we can see it doesn't matter what we give as the password, we know that if it does not work, the length will be 394. So that's one approach to brute forcing your way into the login of an application. There is another approach we can take using a topic we actually have not really touched on in this course yet today, and that is SQL injection. So the idea behind SQL injection is that developers who have written code to interact with a database need to have some sort of SQL or SQL statement that requests data from the database. And you can see how a poorly written SQL statement that accepts user input written here on the screen, where you can see the statement starts with select star, which means select everything from a table named users, where the username equals, and you can see we terminate that string, but then in the next little block we see a double quote, a single quote, followed by another double quote, meaning that the SQL statement, when each of these parts is combined, will have a username that's inside of single quotes within this entire statement. And the same thing happens with the password, where you can see and the password equals, and then in between single quotes is whatever password is provided to this statement. This works provided that you're giving the application legitimate usernames and passwords. It will combine all of these different parts of the string together and create a SQL statement that works just fine, unless we provided malicious input. Looking at this example, we can see the good-hearted user has a select star, again, select everything, from the users table, where the username is something and the password is something else. Now, the select statement for the good-hearted user will either return a user because both the username and password matched, or it may return no user because the username and password you provided it did not match what's in the database. But think about how a malicious user might input some code to circumvent the construction of this string, where the malicious user is going to, again, have the first part of this select statement the same, select star from users, where username equals. Now they gave, if you look up at the top box underneath how it works, the entire input is random username or 1 equals 1. That entire bit gets put into the placeholder for the username, where we can see random username appears in that bottom statement, but then the or 1 equals 1 is still part of this concatenated string because of the terminating single quote after random username. Let's see if we can use this style of SQL injection to bypass the login protections of the OWASP Juice Shop. So perhaps instead of providing admin@juice.shop, perhaps we can do something like giving it a legitimate value like admin, but then we'll terminate the single quote that the poorly formed SQL statement would try to add on our behalf. But by us providing it, we're going to escape that statement early. Say or 1 equals 1 colon to terminate the SQL statement. You want to have a space, 2 hyphens, and another space. As a side note, this space, double dash, space is more specific to a MySQL or MariaDB system, whereas if you're using Oracle or Microsoft SQL, there are some differences in SQL syntax, but for the sake of this example, let's just go with the space dash dash space. So again, the space dash dash space, very important to keep on here. Let's try to log in and see what happens. Well, I don't want to save this, but we can see that we did successfully log in with the administrator's account. If you're curious how it was that we logged in as an administrator, we have to think back to the example we saw just a moment ago. If you think about what happens when a SQL statement is executed, and this could be for the good-hearted user or the malicious user, it's going to select everything from users where the username and password match. To say this another way, it's going to select everything provided the SQL statement finds anything. If it finds anything, it's going to return you everything. And with a login page, more than likely, it's going to chop off the array that it will probably have, again, because it's selecting star. It's selecting everything. There could be more than one. But the API will only return one user, and it will return to you the first user in the list. More than likely, the user at index 0 of the table in the database is going to be the administrative user, because they're generally the first user that gets created when the application is pushed into production. Therefore, it doesn't matter what username we provided. We said admin. But we could have said John Doe, we could have said Jane Doe, we could have said my dog Bucky. It doesn't matter. It's still going to find all of the users because of that or 1 equals 1. Logically, 1 equals 1. It's true. So the statement becomes select star, select all the users from the users table, where the username is the one I provided, or as long as the statement returns true. Because 1 equals 1, it will return true, and it will return all users. Coming back to our scoreboard, we can find that we have solved officially 5 of the dozens of vulnerabilities that exist in this application. We've even solved 5% of them. I don't know if that means there's 100 vulnerabilities in here. I didn't bother to count, but you get the idea. There's so much more to explore in the OWASP Juice Shop. There are entire courses on Udemy about solving each individual item. You can find videos on YouTube. Some of them will be very relevant to web application developers, and some won't. I definitely encourage you to go read the Pwning Juice Shop book. Work your way through an example a day. It'll teach you so much about the ins and outs of how to interact with the web server, how to think like an attacker from different perspectives, and moreover, it will teach you the things you should be thinking about as a developer to keep your application safe.